Global Resource Engineering Limited is proud to present our proposal for the 2018 Disrupt Mining competition sponsored by Goldcorp. GRE has developed a proprietary CoMet analytical technique that employs modern statistical methods to map relationships between diverse ore characteristics and metallurgical performance. The net result is vastly improved resource knowledge and project economics. Goldcorp's mission is to improve existing project production and economics by 20% by the year 2021. GRE believes it can significantly contribute to this effort by utilizing technologies commonly used in medicine and biologic systems to define relationships between geology, mineralogy, and metallurgical test work. These relationships can be utilized to develop a predictive metallurgical model, which allows us to adapt to changing ore conditions and to greatly improve overall project performance and economics. There are many characteristics that influence the ultimate value of a given ore block. These variables can have constant values across an ore body or be highly divergent, even on a block-by-block basis. This is the world of geometallurgy. Understanding the relationships and being able to predict the metallurgical performance is critical to being able to find a path to optimize resource utilization. GRE has successfully constructed state-of-the-art feasibility-level geometallurgical models that utilize non-parametric statistics and multivariate adaptive regression splines, or MARS, to improve the understanding of metallurgical response for projects and operating mines alike. Having a method to accurately predict metallurgical performance is more than just improved recovery. It is optimization across a full spectrum of constraints: available power, production bottlenecks, haulage distance, flow sheets options, and the like. Having an accurate model of ore performance provides the knowledge required to make the right decisions and ultimately improve the overall economic performance of the mine. The geometallurgical approach starts with building an understanding of the ore characteristics, using data from drill logs, met test work, QuemScan, and assays, and then using geostatistics to inform this to the block model. From there, the MARS model is developed by generating ore relationships and equations of metallurgical performance using the components of the ore blocks. The MARS model becomes the knowledge base behind the resource estimation, mine plans, and production schedules. These components have become the foundation of GRE's feasibility studies. In GRE's original approaches, the MARS model was retired after this stage. GRE proposes that the MARS model live on as an integral part of the production planning for both the mine and the mill. Using blast hole assays and other data, the model can produce performance forecasts that allow the mine to make decisions on ore deportment, and for the mill to change operating parameters such as reagent schemes. The net result is optimized production. How are these concepts applied in production? The blast hole data is used to drive production decisions. Where should this ore go? How should it be treated? All driven by the MARS equations. The blast hole data is fed into the MARS model, assigning it geometallurgical characteristics from the blast hole pattern geology. The mill can utilize the production forecast to adjust operating parameters to suit the incoming ore. Machine learning is incorporated to provide a model/performance feedback loop, ensuring that the model becomes more accurate as more feedback is generated. As an example, in the traditional approach, an ore type was often assigned a single average recovery. As shown here, the predicted lead rougher recovery was set at 78%, when in reality the data is dispersed both above and below this average. Contrast that approach to the MARS model, and the correlation between observed and predicted lead recovery improves dramatically. Imagine what happens to mine economics when the design of the mine is based on the second graph, not the first. This type of predictive performance can be applied in ongoing operations as well, to provide a better understanding of ore performance and to allow time to make better production decisions. GRE is excited by the Disrupt Mining objectives and believes that our proposal offers an innovative approach to building intelligent mines, with a direct documented method of improving mine performance. GRE has the expertise to automate the MARS modeling process and to develop a system to allow rapid geometallurgical characterization and ore performance predictions. GRE will demonstrate this knowledge by building a MARS model for an operating mine using feasibility level data, and then further refine that model using historic production statistics. GRE will also integrate a feedback loop into the model via machine learning methodologies to ensure that model accuracy is continuously improved and drift reduced. Finally, GRE will work to ensure that ongoing monitoring is conducted over the life of the mine to capture model performance metrics and improvement concepts. GRE would like to thank you for the opportunity to present our CoMet analytical system. We hope that we can help Goldcorp meet their 2021 goals today.